All right, in this lesson we're going to look at exponential growth and decay models, and the mathematical model for exponential growth or decay is given by this formula right here. N equals n sub 0 e to the kt. You can also use function notation. You could use n of t or f of t. Basically, n sub 0 is your initial amount, n is your amount after time, k is either your growth constant or your decay constant, depending on if it's positive or negative, and t is the amount of time. And this should look familiar because really when we compound continuously, that falls under exponential growth. So if k is greater than 0, that means you're going to have growth. And it's also, this model can be called the law of uninhibited growth. And so k would be the growth rate, and you can see here your function is increasing. So this is what your function would look like. When k is less than 0, and this also can be called the law of uninhibited decay, you can see your function is decreasing. Okay, and that's what your function would look like. So let's just look at an example having to do with the gross domestic product. And basically the gross domestic product is used to measure the economic performance of a country or a region. And it's modeled, or one of the models, is g of t equals 9,743.77 e to the 0.0514 t. So this value right here is our n sub 0. Our growth constant, in this case because it's positive, is k, which is 0.0514, and t is time. And so we ask the first question, find and interpret g sub 0. So let's first find g sub 0, which means we'll just substitute 0 in for t. Now when that happens, this expression right here equals 1, because it's going to be e to the 0. So g sub 0 equals 9743.77, and this is in dollars. So what this means, when g sub 0, when t equals 0, basically that corresponds to the year 2000, which means that according to this model, this is g sub 0, this is our initial amount. Basically when no time has passed. Now, the next question says, according to the model, what should have been the GDP in 2007 and in 2010? And they know here, according to the U.S. Department of Commerce, the GDP in 2007 was 14,369.1 billion, and in 2010 it was 14,657.8 billion. So let's see how close the model came to the actual amount. So I want to know what the GDP was in 2007, so that would correspond to a t value of 7, because we're 7 years after. And in 2010, t would equal 10. So let's evaluate both of these on our calculator. We have g of 7, which would be the 9743.77 e to the 0.514 times 0. And then we want g of 10, which would be the same function, only we will now replace t with 10. I'm sorry, that should be a 7. Let me fix that. To the 7. Okay, let's evaluate these in our calculator. So g of 7 is going to be the 9743.77, second natural log, open parentheses, .0514. My apologies, I left that 0 out. I will fix that in a second. Times 10, excuse me, times 7. All right. And then we'll do g of 10, which is 9743.77. Second function, natural log, e to the, again, that's 0.0514. times 10. Press enter. Alright, so after plugging in the values, and just want to make sure I corrected that, there should have been a 0.05 there. Evaluating this in your calculator, we get 13,963.2 billion for 2007 GDP, and in 2010, $16,291.2 billion. It says, looking at the values that they have, certainly this model is not perfect. It's just a predictor, so it's not going to match the actual values. It's somewhere around there, but certainly not too close. All right, the next question says, according to the model, in what year will the GDP be 18,000 billion, which is really 18 trillion. But let's plug this in. So if I know what the GDP is, that's my g of x, so it's going to be 18,000 equals 9743.77 e to the 0.0514 t. We're trying to solve for t, so we're going to divide each side by 9743.77, so we get 18,000 divided by 9743.77. That equals e to the 0.0514 t. We need to take the natural log of each side, leaving us with the natural log of 18,000 divided by 9,743.77. That's equal to 0.0514 t. We need to divide each side by the 0.0514. So t is going to equal this value right here, and let's plug that in our calculator. All right, we have the natural log of 18,000 divided by 9743.77. Close that and divide that by 0.0514. So this is approximately 11.9 years after 2000, after the year 2000. So t is approximately 12, so this would happen approximately in the year 2012, according to the model. Okay, in the next video, I'd like to start by looking actually at the U.S. website and looking to see their graph of the GDP for this time period.